Nature has an entire suite of disaster at its disposal, and some are more difficult to predict than others like earthquakes. Earthquakes are basically impossible to predict with any real certainty. As we live in an earthquake-prone area, we realize a fundamental truth. Earthquakes don't kill people, but buildings do. Researchers have spent a lot of time wondering how to make buildings safer. So do our group. We intend to give the building an invisible cloak that could give a full protection to the buildings. Stay tuned with us to understand more about this project.
Objective of the study: first, to study about seismic waves that are generated during earthquake. Second, to study about the best material that can absorb and give path for a seismic wave during the earthquake.
Significance of the study. The finding of this study will be a significant endeavor in promoting a better idea to prevent a building from collapse during any havoc wreaked by the force of nature. The greater demand for high-rise design and the construction of building justifies the needs for stronger foundation of a building to be designed. Therefore, the building that apply the recommended approach derived from the result of this study will be able to stay long-lasting. In addition, this study will be beneficial as the building can be maintained properly, free from any damage, and reduce a costly repair bill. The finding of this study will be serving as a good source of accurate and useful information for the future researcher and researcher themselves. Thus, a new design on making a building keep standing during earthquake may be arrived at.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Akmal bin Ranga. My friend and I will present about our final year project. The title is Immortal Construction. Abstract. Earthquakes occur because of Earth rotation and other energy factors differential or the rock layers constantly move or slip past each other. Besides that, it also related to compression of tensional stresses. Volcanic eruptions, rockfall, landslide, and explosion can also cause a quake. The main objective of the study is to find out a suitable material for plate that can absorb seismic wave during the earthquake. Introduction. Do you wondering why we choose the title of Immortal Construction? It is because we want to build a building will stand over everlasting and becomes invisible to natural earth disaster using the plate that can give the wave a way to travel without hit the building. Earthquake is something that is cannot predicted and it can violently shake the building. Malaysia is closer to rumbling areas and will not be forever resistant to earthquake. Most of the nation may feel that the country is generally free from any major active seismic activities as a consequence of its strategic location. Looking back on the tragedy which occurred over 15 years ago, many people did not expect that our country could be hit by the 2004 Indian Ocean tsunami. In June 5, 2015, 5.2 magnitude earthquake struck Sabah, which killed and injured scores of people. Literature review. Natural earthquakes are the shaking of the Earth's surface caused by a sudden release of electric energy from geological fault and generates mechanical wave called seismic wave. The greatest hazard in the earthquake is the collapse or fall of man-made and natural structure that causes the extensive loss of life and property.
There are three basic types of seismic wave. First is P wave, second is S wave, and the third is surface wave. The energy released by the disturbance propagates away from the source of the disturbance as seismic wave. P wave, also known as primary wave or pressure wave, travel at the greatest velocity through the Earth. S wave, also known as secondary wave, shear wave, or shaking wave, are transverse waves that travel slower than P wave. Surface waves are similar in nature to water waves and travel just under the Earth's surface. The earthquake clock ideas come from researchers in the United Kingdom, Italy and France, some of whom were the first to show that the physics of invisibility clock could have other applications, designing a clock that could render objects invisible to destructive storm, wave or tsunami. The seismic wave of an earthquake fall into two main groups: body wave that propagate through the earth and surface wave that travel only across the surface. By turning the clock properties, that path can be made to be an arc that directs surface wave away from an area inside the clock. For each small frequency range, there's one pair of rings that does most of the work. The team has simulated clocks containing as many as 100 rings, says Jenny. Although fewer would be needed to protect against the most common kinds of earthquake surface wave.
Metal rubber is a permeable structure governed by chilly squeezing space into flexible components from the metal welding wrapped up by shape and scale, which will additionally frame into vibration insulators. In vibration insulator system, the application effectiveness of vibration insulators dependent on metal rubber material is primarily dictated by its flexible and quality properties. Metal rubber has a wide range of possible applications, from mechanical flexible electrical interconnection and electromagnetic shielding to the measurement of large mechanical deformations. Shape memory over superelasticity is a different property that makes it superelastic. Excellent for seismic reinforcement. A shape memory alloy superelastic may instantly restore its initial form, even from its inelastic. That's all from me. Thank you.
My name is Muhammad Alif Iqbal. Let's proceed to the next part, which is metallurgy. From what we have studied, the plate will be buried in 1 meter depth under the building. The plate actually acts as wave absorber or shock absorber that will prevent the building from collapse during the earthquake. During the earthquake, seismic wave is produced that contain body wave and surface wave. The wave will travel to the plate that's compressed into tiny fluctuations in pressure and density. The plate material play an important role to give way to seismic wave during the earthquake. A few materials had been chosen to its own characteristic and ability to absorb and repel the wave. This figure shows the illustration of the plate will be buried under the building. This is shown how the plate is made out. The inner core of the plate is made out from rubber. The next layer would be metal rubber, and they are constructed repeatedly and simultaneously until the outer layer of the plate. Each strip is different the farther out they are from the core. Outer layer of plate is made out from concrete. Concrete is very strong, stiff, the material that can withstand without yielding, great tensile and compressive stress. The wave will exit the plate, they will return to their previous larger size. Next is result. Rubber has been chosen as the inner material of the plate. Rubber is composed of long chains consist of at least 10,000 similar chemical units. The figures show the chemical structure of natural rubber as polyisoprene. Rubber is used in many things because of its characteristic and ability. Rubber also is of handling and installation, energy storage capacity, an ability to convert some energy to heat when it is deflected. Natural rubber without fillers exhibit very little hysteresis, and as a result it provides energy dissipation or damping in a system subject to vibrational force. Stiffness of the metal rubber. The figure A shown the graph due to the effect of elastic stiffness softening and damping enhancement of metal rubber. The dynamic average stiffness decreased with the increase of amplitude. For the figure B, the dynamic average stiffness of metal rubber decreased with the increase of the frequency. This figure shows the change of component of total deformation of elastic damping element during practicing for the figure 1, while the figure 2 shows the dependence of relative permanent deformation on the relative strength of loading. The image reveals the sky view of the plate meanwhile the building is over the plate. The plate construct is an earthquake-proof barrier for the building to be protected during the earthquake. This is a kind of waveguide that reduces exponentially the amplitude of the dangerous seismic wave.
Hello everyone, I'm Aminuddin. So let us continue to the next part, which is the discussion. So, the causes of earthquake could be an earth rotation where differential or rock layers constantly move or slip past each other. Besides that, tensional stress can also cause earthquake to happen. Tensional stress is a stress that tends to pull something apart. Lastly, natural disasters such as volcanic eruption, rockfall, landslide, and explosion are also considered as the causes of earthquake. Our project was inspired by these two research. The first one was from the researchers in France, where they have proposed an idea to protect building against earthquake with seismic invisibility cloak. In theory, the idea may be applied to build defensive barriers that redirect earthquake energy away from the building. The second one was from the study posted in the journal Creative Infrastructure Solutions, where they proposed that a building district could be considered a set of above-ground resonators. In short, they mean that the building may be used to dissipate the energy of seismic wave. Alternatively, the building could bend away the wave. As a result, we propose to design a plate that has been discussed in methodology. Since this study are related to earthquake, so research on seismic wave which is generated during earthquake is also carried out. And basically there are two types of seismic wave, which is the surface wave and body wave. But we only focus on body wave in this project because body wave are more destructive than surface wave. A body wave is a seismic wave that travels through the interior of the earth, divided into two, which is the P wave and also S wave. The difference between P wave and S wave is P wave shake the ground in the direction they propagate, while S wave converts the wave to the direction of propagation. The equations that are related to this study are the three-dimensional wave equation of S wave and P waves. The three-dimensional wave equation is a linear homogeneous partial difference equation with constant coefficients. It has one dependent variable and four independent variables. So this is the P wave equation and the S wave equation. This equation describes the seismic longitudinal wave and shear wave. Therefore, the wave velocity of P wave and S wave are also stated here. In conclusion, this final year project report has proposed a method to protect buildings against seismic wave which is generated during the earthquake by burying a 1 meter diameter of plate underneath the ground. On top of that, research on seismic wave are done to relate with the properties of the plate suggested in this project to ensure the plate can give a successful protection to the building. The plate is suggested to be comprises of number of large concentric rings which is made by different types of materials. Each ring would have different stiffness and elasticity to be controlled so the wave can pass smoothly into the materials. By tuning the properties of the material of the plate, that path can be made to be an arc that directs surface waves away from the plate. Therefore, research on the best material of the plate were also carried out throughout the study. From the result and discussion, the material of the plate would be rubber, metal rubber, and concrete. This plate is coated with nanofiber. The result of the material of the plate can be summarized in the table below. For the future project, hopefully the concept of the metal which was approached in this study can be designed successfully and produce the expected result. This plate can give an invisible cloak to the building to withstand the earthquake. It is essential to ensure correct construction of the plate from the core to the outer layer, which is challenging because their properties need to be tuned to direct the waves away from the building. Therefore, more study and research has to be done on that matter in order to make this plate a successful method to protect buildings against natural disasters.